Hello there, and welcome back to this next workshop that we've got here in ClueCon, TGI 2021. We're here all day today and all day tomorrow, Central Time, with great workshops, great speaking sessions as well. This first speaking session kicking off at 2:30 p.m. this afternoon. But right now, we've got two for the price of one. Put your money away. It's all included in the ticket price. We've got Bogdan and Răzvan. Let's say hello to you first, Bogdan. How are you today?
First, hi David, hi everyone. I'm fine. To be honest, I'm looking forward to end the dates quite late over here. So yeah, we are the lucky ones checking the list for today. But nevertheless, we want to to share some great stuff with you before doing that.
Okay, that's very kind, Bogdan, for you to be staying up for us. We appreciate it. Răzvan, you're looking a little bit more hairy than I remember you.
Yes, I am. This is the pandemic effect, right?
Looking good. Okay, well, look, gents, I don't want to stand in your way of getting on with the excellent workshop you have planned. So I'm going to sit back and hand over to you two. Thank you very much.
Thank you, David.
Thank you, David.
Right. So today we prepared together with Răzvan a quite interesting workshop with OpenSIPS, showing what very interesting things you can do with the latest releases. Latest releases meaning it's a combination between the latest 3.1 release and some upcoming cool stuff that we have for the 3.2 release. Basically, it's about routing, but not let's say the usual static, quite simple routing, but some routing, dynamic kind of routing based on quality, because at the end of the day, quality is a very important thing when it comes to making having a communication. Right, we'll call it basic, but we want quality, and we want to have a system that it's able to dynamically auto adjust based on the quality of these calls. Well, yeah, of course, it will be about OpenSIPS, and we will see how we can do this kind of routing using a lot of scripting. So the fact that we can program OpenSIPS with a lot of modules we're going to use, and we see that we're going to involve a couple of modules for that. And of course, we're going to do a lot of traffic. So these are the main things we want to have. So what we will cover actually in this. First, we'll start showing, okay, how you can simply monitor your traffic using script statistic. That will be the entry point in this workshop. And then we say, okay, simple statistics are not enough. We want some time statistics. We want to see how different parameters of the traffic do evolve in time, to have a history, to have different kind of histories, and to see the differences, to see the details versus, generic fluctuations in the traffic. So that's the next step. After that, we will see, okay, how we can grab these statistics from OpenSIPS very nicely and push them into Prometheus, visualize them with the Grafana. That's the next step. And then once we have the access to the data, so basically we do the monitoring, we say, okay, let's create a kind of a feedback loop, feed them into the routing engine of OpenSIPS, and do dynamic routing based on the quality, basically to decide, okay, which gateways you want to use for calls based on the real-time computed quality of the gateway. So that's one of the interesting parts. In the first part, we will collect, let's say, quality information based on the SIP traffic, but we will show you how you can also do it with media statistics. So basically to extract the most information, feed it into the quality-based routing engine in order to to do it. So let's quickly see what will be the setup that we will be using during this workshop. Of course, in the middle of the OpenSIPS, acting as a SIP proxy, we will use an CPP to generate traffic, to continuously generate traffic into our proxy. And the proxy by default, it will start doing some very simple routing, basically routing to a single destination, to a single prefix, with the prefix pointing to. So basically, the traffic for a certain prefix is split in two gateways, gateway 1 and gateway 2. And the idea is we will have control over these gateways in terms of changing different kind of properties of the gateways, like the PDD, the setup time, the call duration, and so on, individually for the gateways. And then we want to see first to monitor from the OpenSIP side, so from the SIP proxy side, to detect in real time this fluctuation of the gateway's property in terms of traffic quality, and then to create this feedback loop into the routing, so to adjust the distribution of the calls between the two destinations, between the gateway 1 and gateway 2, according to the quality. The end goal is we want to use as much as possible, of course, the gateway with the best quality. Just as a short inside information, of course, gateway 1 and gateway 2 are actually also two OpenSIPs, because we like how flexible it is, OpenSIPs, and we are able to program and have this dynamic part for the PDD setup time and so on. So as we said, we're going to start with the traffic monitoring, and these are the kind of typical statistics that you may monitor for the traffic. It's not limited to, but let's say they are the most used one. And as you can see, all of them are SIP signaling based, so they don't have anything to do with the quality of the audio, of the media, let's say. Can be video also. It's only about the signaling. And based on these statistics, you can get an idea of about the level of health of the traffic or of the gateway. So you can say, yeah, okay, this is a good gateway for traffic, for termination, or not. So we just listed here because, again, we will use them during this workshop. With OpenSIPS, you can create dynamically at the script level some, statistics. It's not, there is nothing fancy. That's as I said, the entry point. The idea with these statistics, they are really kind of real-time simple counters. Basically, they lack any kind of aggregation, so they reflect a single value. So you cannot collect values from multiple, let's say, sampling points, like let's say to take a value from each call and aggregate. You cannot do that with these. And secondly, they don't have any kind of a history, so it's just a value and that's it. They don't have a window in order to keep some history to see the fluctuation. It's just a value and that's it. So they're not quite useful as they are. I mean, you can count how many calls you did, you can count how many registrations you have and stuff like that, so basic things, but you cannot do real monitoring in order to detect how the quality fluctuates in time. So for that, starting with 3.2, we said, okay, let's have actually built-in support. As a note, OpenSIPS 3.2, it's the next release sometimes this year. So we said, okay, let's add time series statistics. So basically, these statistics, new kind of statistics, they bring two new concepts. First, it's the aggregation algorithm. So you collect the information like the PDD, the post dial delay, from from many calls. It's not from a single call. So, and the question is, how do you aggregate these values in order to get a single PDD value? So you see, you have algorithms like percentage, average, or simply accumulate like a counter, and so on. And the second property is the history, which is this window. So it's not just the real-time value, so the right now value. You can calculate, okay, what is the PDD on with a certain history. So like the PDD on the last minute, PDD over the last 10 minutes, the PDD over the last day. So you can see how the quality fluctuates with with a different history. So maybe you want to see the small spikes that may happen, so like the details, versus you want to see what is the average behavior of the gateway during a day in terms of quality of the PDD, let's say. So you can create different windows in order to get the different views over the statistic. So how you actually use, for example, such time series statistics in the script? You define the statistics as previously. So saying, okay, what's the algorithm, aggregation algorithm, and what is the buffering window? So the history actually. And then in the script, it's very, very simple. Let's say a typical example here with the PDD. Let's say, okay, the call was, you are in the setup time of the call. You can compute the PDD based on the incoming 180. So at the script level, it's just doing a mathematical operation just to calculate the PDD for the current call. And then you just do update the statistic Syria with the value of the PDD. And okay, that's a name of the statistics. And you can see the name, it can be something dynamic. Basically, you can create statistics per gateways, per carrier, per customer, per whatever you want. So you have the liberty to dynamically create them as a name, so the statistic itself. And similar, for example, if you want to do it for the ASR, for the average user ratio. In that case, it's a percentage. So the PDD, it's a value, hopefully not more than, I don't know, let's say 300 or 100 milliseconds or whatever. While the ASR, it's a percentage. So you see, it will be included in a different class of statistics, the ones calculating with percentage, not with average. And similarly, it's the name of the statistic, and we just put, in this case, it's more like 1, the value. So that's a very, again, simple way of using. I wanted to show a bit, let's say, the background of this, and now I will let Răzvan actually to show you the real stuff. So to go through to the OpenSIPS configuration for this, how the elements are put together, and actually, run some calls and see some results over here. So yeah, let's switch to Răzvan.
Thank you, Bogdan. Can you please share my screen now? You see? There you go. Thank you. So this is the OpenSIPS script that we've been using for generating these statistics, and basically what it implements is exactly what Bogdan described up until now. Let's see. I have here some markers, stats. So the first thing that we have to do is to load the statistics module. This is the module that provides all these statistics series and allows us to configure. Next, as Bogdan said, we need to define some sort of profiles or provide the description of how these statistics should be aggregated. In our example, we are using 3 different profiles. We're using percentage, average, and accumulate. Each of them with a window of 30 seconds in order to be to be more accurate. We don't want to have like real time, but we don't have want to have like 1 hour or 10 minutes windows, because this will make our test far harder to follow. Next, in this script, what we need to do is hook on each of the events that might alter these statistics. We will be using 2 different events. Actually 3 different ones. One of them are for replies. A different event is for stars. So we are using the CDRs because we want to find out the duration of the call in order to compute the average call duration statistics. And we are also interested in the missed events. The missed events are we are using in order to compute, for example, the ASR, the average seizure ratio. Next, what we will do is get an accurate time. This function returns the actual second and millisecond this call started. And we are also storing an extra. We are storing the gateway that we will be using during this call in a special variable in our counting extra values, and then calculate these statistics. Basically, what the first statistic that we will be calculating is the total number of calls. So once we get and assign it to a gateway, send it to a gateway, we need to increase the value of that counter. We are using the accumulator, the ACC profile, because the number of calls will basically accumulate over time, right? Next. Here, we are computing statistics based on the replies we receive. We are only counting positive replies. That's because the negative ones are counted in the missed call event. So here we compute the PDD, and after we compute it, we update its own series, saying, "Hey, update my stat series using the average algorithm with the PDD for this call." And if the call was successful, also update the answer seizure rate. We mark it as 1 because it's a positive. It's a positive percentage. The NER and the call completion ratio, the CCR, also positive. All of these are positive. We also compute and update the average setup time using the number of milliseconds this call took to set up. Next, we have the CDR event, which we will be using in order to compute the average call duration. There you go. So what we will be updating is the statistic for the call. And finally, the missed call event, which will basically update all the other statistics. But as you can see, with a negative value in case of, for example, the CCR should be negative if the response code is higher than 500. The NER should be decremented or counted as a negative percentage if the response is negative, but it's not a user busy, like a 487. ASR is always decremented. So now that we have all these statistics, what we can do is, the first thing that we can do is show them. How do we get these statistics? Get statistics. There we go. So I'm currently running, I don't know, I think 10,000 calls through through a CPP, and sending them, as Bogdan said, sending them to 2 different gateways. Those gateways behave the same, like almost the same. And these are the statistics that are gathered. Of course, these statistics are nice, but they are not quite that easy to read. So that's why we will be using Grafana in order to monitor this. And this is the tab, our Grafana tab that shows us the behavior of our gateways. As you can see here, both gateways are the same. So more or less all the statistics are the same. Here it does fluctuate, but it's just between 101 and 102 milliseconds. So yeah, it's probably expected, similar the average setup time. And here we have the total number of calls. I'm sending roughly 10 calls per second, which for statistics of 30 seconds means like 300 calls, which are distributed roughly between 140 and 160 calls between the two gateways. The initial algorithm for distributed calls is more random, which offers, as you can see, a roughly similar distribution over the gateways, right? All right. The next thing that we need to do, so besides gathering these statistics, is pushing them to Prometheus, and from there grab them in this nice Grafana graphic. So in order to do this, actually, I will leave Bogdan show you how this can be done. It's quite simple. So Bogdan, go ahead.
Yeah, let's go back to the boring slides for a second, just to. Okay, thank you. To see how to do that. So we said let's use Prometheus for collecting the data, and then Grafana to visualize, because it's it's a nice and easy to integrate way of monitoring the statistics. Right now, in OpenSIPS, you can very easily you can easily add, you can easily push, the statistics to Prometheus actually without the need of any additional support. It's, if I may say so, just abusing the REST API provided by Prometheus. So in this example, I'm using a timer route inside OpenSIPS every let's say 10 seconds or whatever. And inside, using an iterator, I'm iterating through the statistics. So basically, that's the class of the statistic, the stats, and I have an iterator. And then using the iterator, I'm just fetching each statistic and its value. And for each of it, I'm doing a REST post query through HTTP to Prometheus in order to set the statistics, so to upload the statistic and its value. So that's a very nice exercise in how you can do a lot of cool stuff with the script support of OpenSIPS, like in here, iterating through some statistics and pushing them through HTTP to an external repository. Nevertheless, we are working for the 3.2. It's on the roadmap to actually get some built-in support for Prometheus. So basically, you don't have to do this from through HTTP from the script, but through a nice built-in backend. But okay, that's a different story. So anyhow, if you need to quickly push stuff to Prometheus, you can do it like this. You don't need any external additional daemon or interfacing or whatever. Just do it in this way. So let's see now Răzvan. Going back to Răzvan to see once looking at the Grafana charts, we will start changing the properties of the gateways, and in terms of different parameters, and the end result will be we see the changes on the charts. So Răzvan.
Thank you, Bogdan, and thank you, Casey. So now, getting back to this graphic, we've seen how we are pushing these statistics. We're seeing that we're kind of sending the same statistic to the gateway. That's because we are only doing a weight-based algorithm for balancing, which is basically we have this gateway set up with 50-50 chances to get calls. So that's why we are seeing a linear, roughly the same calls are going through through each gateway. What we will try to do now is to see how these statistics fluctuate when the gateways fluctuate. So what I'm going to do now is tune one of the gateways, let's say the first gateway, gateway 0, tune its PDD. What will happen is, instead of responding with a 180, the user agent server, so the UAS, the callee of each call, will, in this case, each gateway will return, will use a different delay. So basically, we'll use a different value to sleep before sending 180. To do this, I'm using a tool I've developed. So, okay, these are the current statistics that we are using. So, for example, now each gateway is sending a PDD between 100 millisecond and 100, so basically 100 milliseconds. This is for both UAS 1 and UAS 2, so gateway 1 and gateway 2. But now we want to set a different PDD for instance 1. Instead of using 100 milliseconds, let's say let's do 150 to 250. Okay. Let's see if this was updated. Yes. So here, what this tool shows us is that the user agent server will respond to a call a bit harder. So instead of responding in 100 milliseconds, it will use a random value between 150 and 250. We can see that this immediately reflects in our Grafana graph. So here, as you can see, gateway 1 will continue responding with PDD 101. However, gateway 0 is using an average value of 150 up until now. It will probably increase over time. Let's see. Yeah. So now we have 198. Okay, so as you can see, the PDD for gateway 1 is between 150 and 100 and 250. Of course, the average setup time also gets affected. Up until now, we were using 500 milliseconds each gateway, but since the PDD increased, it's normal that the average setup time should also be increased. So that's what we are seeing here. Let's play a bit with, for example, the call completion ratio, right? So as you can see, we currently have a 100% success rate for each call. What if we decrease this success rate for the same gateway, for gateway 0, decrease it to 80%? So instead of answering each call, 80% of them will be declined. We should get this the feedback of this statistic in the answer seizure ratio. That's because instead of answering all the calls, like having 100% success rate, we're now having 97% rate for gateway 0. Of course, for gateway 1, we will still have 100%. That's because we haven't tuned it. The call completion ratio is also affected, right? Instead of having a 100% call completion completed calls, we only have 98%.
What would be interesting to say here, because each time when you prepare a workshop, you have to keep a very fine balance between how many cool stuff you want to show versus how complicated it will be, after all, for the participants to understand. So we have for each statistics, in this case, we have a single. Actually, let's say for each parameter, we have a single statistic. For the PDD, we have just the PDD with, I think it's a couple of seconds history. Normally, when you actually do real-life monitoring for the same parameter, you usually do monitoring with different histories. For example, you do like a history of 1 minute if you want to see the small fluctuations of the parameter, but in the same time you can do with a couple of hours history if you just want to see overall how bad or good that parameter happens. In our case here, we have a quite short history, just because we don't want to spend like 3 hours running the demo. But again, all these parameters you can take and very easily use them with a different history in order to see different granularities in terms of the fluctuation.
That is correct. Thank you, Bogdan. What's interesting to note is that the number of calls here are basically the same, right, for the two gateways. It's also between 140 and 160, but it's more or less the same calls are going to each of the gateway, regardless that one of them, in this example, gateway 1, is behaving a bit slower than the other one. And that's because, as I said, up until now, we've been doing simply weight-based balancing.
Yeah, there is no feedback loop for the routing, so we are just monitoring. The routing decision, it's still the same, like basically splitting 50-50 the traffic between the two destinations, the two gateways. Sorry.
Okay, and now Bogdan will show you how we can change this.
Yeah. So again, back to the slides, and let's do more magic. Magic meaning creating the actual feedback loop. So taking this monitoring information that we are able now to compute based on the ongoing traffic, feed it into a routing engine, and let the engine decide how the traffic should be split between the two gateways. Because the whole idea with the quality-based routing is to monitor all these statistics of the gateway, so to see what is the performance of the gateway. So it's a self-monitoring, and based on different kind of profiles, the end result is to dynamically balance the traffic between the gateways in such a way that most of the traffic goes to the best quality gateway. So we want to favorize, or let's put it the other way around, we want to take the traffic out from the bad gateway. So to identify gateways behaving badly in terms of quality, and to avoid sending traffic to them. So that's what the feedback loop is doing. And now that we are able to monitor all these statistics in the quality routing module in OpenSIPS, that's a new addition for the 3.1 version, you can create profiles for the gateway. Basically, a profile, it's a set of parameters saying when and how let's say, the quality of the gateway changes. For example, you have several thresholds saying, okay, traffic, the quality of the gateway, it's bad or really, really bad. And how much traffic penalty, like how much traffic should be cut off from that gateways for the so-called warning or critical penalty. Of course, things are more complicated because you have multiple statistics. You have to evaluate each of them and then to put them together in order to get an overall score for the in terms of quality for the gateway. And then once each gateway has a score, the engine will rebalance in terms of traffic. Of course, better quality, meaning higher chances of using that gateway. So, for example, some values that we have in in the database for the profile for the PDD, we have a warning threshold of 300. So the value of the statistic depends actually on the meaning of the statistic. So once we get over 300 milliseconds of PDD, we want to say, okay, it's a warning. So something it's not good. And the critical value if it goes over 500. And the two thresholds are correlated with two penalties. We have the warning penalty and the critical penalty. So whenever the warning threshold is reached, automatically there will be the warning penalty applied. And you can decide the factor of reducing the traffic. So in this case, it's a 0.5. So basically that gateway will start receiving only half of the normal traffic. And you can see there is a similar critical penalty, which is in this case 0.05. So basically, if the PDD goes higher than 500, then only that gateway will receive only 5% of normal traffic comparing with the remaining gateways in the list. So you start cutting down traffic from the gateways. And of course, if you take a look at the module for each statistics, you can put your own values. You can create different profiles. So you can use for different situations with different penalties. So it's very flexible and really easy to use. It's easy to provision, but when it comes to actually using into OpenSIPS config file, it's like really peanuts. So what you have to do is just actually load the module. So it's saying, okay, I want to use this quality routing module, and just update your dynamic routing information. So basically that's information used by the dynamic routing where you have prefixes and all these gateways defined. And in the routing rules, you just say, okay, I want to use as a sort algorithm. So the way the gateways are sorted, are ordered, I want to use the quality one. This quality is provided, of course, by the quality routing. By default, as we had so far, the algorithm is just keep the list as it is. So there is no reordering. It's weight-based. It's a kind of a static algorithm. But the dynamic routing module in OpenSIPS allows other modules to come with whatever other algorithms in order to order the gateways. So in this case, you can simply specify, I want to use the Q algorithm from the quality, and you are done. Nothing to do. So it's really trivial to activate this quality routing in OpenSIPS. So now going back to the real stuff, to the practical side, Răzvan will actually enable, let's say, the quality routing in the script that's already configured over there. We will just enable in the database, and we will start again playing with the properties of the gateway. So basically changing the quality of the gateway. But this time we will see that this will have an immediate effect on the routing decision. So it will not have that 50-50 distribution that we had so far. The routing will start responding dynamically to the changes of the quality. So yeah, let's go back to Răzvan's sharing.
Thank you. Okay, so the setup is the same that we left it. So for gateway 0, we're generating a PDD between 150 and 250. Gateway 1 is 100 milliseconds. Again, as you can see, this fluctuates. Nothing has changed. An important okay, the current setup here, as Bogdan said, in the DR rules, is to use to have the sorting algorithm weight based. So as you can see, for no prefix, this is like a wildcard prefix, we're sending calls to either gateway 0 or gateway 1 with 50-50 chances of reaching traffic. However, if you want to use the quality-based routing, we should be changing this sorting algorithm to queue-based. When we do that, it will be using the sort profile tool. Let's see how. Select star from QR profiles. Let's see how this profile looks like. So we as Bogdan said, we set a couple of thresholds. For example, if the PDD exceeds 300, we should we are passing a warning threshold. When we do that, we get penalized with half of the traffic. However, if we pass the 500 PDD, then we are penalized with 0.5. We're currently only setting the PDD and the MOS warning and critical thresholds, and we'll play with MOS a bit later. But now let's make the gateway as bad as bad as possible in order to reach this warning. So instead of we're currently for gateway 0, we are using 150 and 250. Let's do it somewhere between 300 and 400. This will modify the PDD of gateway 0, and instead of having an average of 200, it will probably have like 350, right? However, the total number of calls distribution should not change, at least not yet. That's because we haven't updated our algorithm. We are still routing based on weight-based algorithm. So we should not see any changes in the total number of calls. As you can see, the average PDD for the last 30 seconds, as we've configured, starts gradually change and gets increased from 0 to 325. Right. So at this point, we have reached our quality threshold, and we should get penalized. However, we are not. As you will see, calls will go the same, and that's because we haven't. We're not using we are not using the quality routing algorithm. Okay. As you can see, we don't have any updates here, right? So let's start routing based on quality. Okay. In order to do that, all we have to do is change the algorithm to queue from quality. And we shall also reload OpenSIPS in order to update its cache and make sure we are using this this new setting. So as you can see, we immediately get some statistics from the quality routing module. So we get ASR, CCR, currently only for gateway 0 because probably gateway 1 didn't get enough data. Let's see. Yeah, started to get data from gateway 1 as well. If you take a look, you'll see that the statistics are basically the same here. So now that we've updated the PDD, which has an average of 350 for gateway 0, and updated our quality routing statistics, now we should see some changes. What should happen is that gateway 0 should start receiving less calls, like half of the calls, and gateway 1 receive double the calls of gateway 0. And that's because we are cutting off half of the calls that should have gone to gateway 0. As you can see, this starts to reflect in this in our graphic. Right? Instead of fluctuating between the same value, between 140 and 150, we're starting to get 100 calls for gateway 0 and 200 calls in gateway 1. Okay, let's give it a bit more time. There we go. So now it's clear that the distribution of the call is not the same. And that's because we have a bad quality for gateway 0. All right. Of course, we can play with other statistics as well. We can change the average setup time and set to a value that goes through the threshold, but we haven't set a threshold yet. All the others can be configured as well, as you've already seen, but that's not it. Some other statistics that for example, we might have not thought of can be also fed in the quality-based routing. And Bogdan is going to show you an example of these other statistics. So let's go back to Bogdan's slides, please.
Yep. Yeah, so right now, Răzvan just messed up with the gateway 0 in terms of increasing the PDD, so basically decreasing the quality. And next step, what we want to show is how you can actually combine multiple statistics in order to control the routing, so not just the PDD. And for this purpose, let's look at the MOS statistics, which is also interesting because first of all, it's a media reflecting statistic, so it reflects the quality of the RTP, so it's not signaling related. And also to show how easily you can expand the monitoring and the quality routing in the module by adding custom statistics, because what we had so far over there, so things that already shown by Răzvan, they are the built-in statistics that the module is able to automatically compute based on the traffic, but it's not limited to that. Your own statistics, like for example, we had before the time series, so you can create whatever statistic and then you can feed it into the quality routing module with no problem. So we're going to do that with the MOS statistics. So what you have to do is just to instruct the module, hey, I just want to use an extra custom statistic. That's the name, the MOS, and says you have a plus in front just to instruct the module, okay, what is the fluctuation, meaning if the value increases what happens with the quality. Is it better or worse? Because some of them are the other way around, like for example the PDD, big PDD, bad quality. So you just need to know the module, okay, how to interpret the fluctuations. And then what you have to do is just to feed this MOS statistic into the module, because again, the module doesn't know how to fetch, to compute this value, so it relies on you at the script level to compute and just feed it into the module. In this example, what we do if we have a buy request, we use the quality routing set extra statistic. There are some, okay, you need to specify for what rule and what gateway you have to push this extra statistic. So there are 2 parameters. Then we have the MOS. So, okay, I want to push this MOS value. And then it's the actual value. This actual value in this example normally should be taken from the RTP engine statistics. So the RTP engine is able to deliver to OpenSIPS the statistics about the MOS value at the end of the call. So we grab it at the script level and at the buy time. So when the RTP session was ended through RTP engine, and we push this value into the quality routing module. So just keep in mind, you have to do this somewhere after you end the session with RTP engine. So it's very simple. I have RTP engine, it delivers me the MOS through a specific statistic, a per call value. I take this value, I push it into the quality routing module, and the quality routing module is doing all the magic in terms of aggregating, doing the history, and so on. So it starts computing the value of this statistic. Of course, we need to do some database changes. So we need to add the related columns into the profile, because we want to set, okay, what is the threshold? What are the thresholds for the warning and critical? So similar, like, okay, if it becomes lower than 4, then okay, it's a warning. If it's critical, if it's below 2, and of course the penalty. So just expand the profile table just to add this new statistic, and then populate the value. It's quite simple. And then the module will just do everything for you. So you can again come up with whatever statistics you may want to reflect the quality of the gateway. You can feed it into the quality routing module, and then the module will just compute it. It will chart it, do the history for it, and set the score for the gateways. So yeah, let's see how going back to Răzvan. Let's see how this works, and we will try something cool. Now that previously Răzvan messed up with the gateway 0 in terms of PDD, let's be even, let's say, let's be really evil and start messing up with gateway number 1, so with the other gateway, but in terms of MOS, so in terms of the media quality. And okay, let's see what will happen. So yeah, Răzvan. Maybe before starting, as a short note, we don't on this in this workshop we are not actually using any RTP or anything like RTP engine. We are just simulating some, so pushing through SIP headers the MOS value just for the sake of the workshop. But you know, integrating it with the RTP engine, it's quite simple. But again, we didn't want to complicate things over.
Correct. Sorry, I started earlier and I was muted. So as you can see here, both gateways currently report a 5 MOS score. This is the mean appearance score of the media. And that's because, according to our setup, both gateways are used to deliver MOS value between 500 and 500. So basically a perfect score for MOS. And as Bogdan said, for PDD that we played with gateway 0 and made it worse so that it get less traffic. Let's now play with gateway 1 and see what happens. So instead of using a 500 MOS score, let's set a lower value, for example, between 300 and 400. This will translate to a MOS value between 3 and 4, because we divide the MOS value by 100 to get the actual score. So we're altering for instance 1, and we're using something between 300 and 400. All right, let's see how this affects our graphic. We haven't plotted the MOS value, so we will not exactly see how the MOS value fluctuates. Of course, we can check the QR status. And as you can see, the quality of gateway 1 starts to degrade. So from a clean 5 score, we're starting to get like 495, 493. And it will soon be degraded even more. What's interesting is that getting back to the quality profile is that for a bad PDD, so a PDD higher than 300, we penalized the gateways with 0.5. So we penalize it so that it will only get half of the traffic. With MOS, we do it even worse. So instead of if a MOS value is below 4, then we will have a 66% penalty. Actually, we will only send 33% of the traffic to that gateway. So if we compute this means that gateway 1 should start to get even less traffic than gateway 0. Sorry, and this is actually what we will probably start seeing here. Not sure if the value converged. Let's see. Yet. No, we're still with a 4.7 average MOS. That's because the queue routing history is like 60 seconds, I think, or not sure. I'll have to check that. Then let's make it worse. Let's generate a 300, a 3-score MOS value. Make sure it gets worse even faster. Let's be mean. Let's use 230.
Yeah, that's the whole idea with the history. You need to define, okay, what is the time sampling time, sampling window. What's relevant, for your scenario. So how fast actually you want to have these changes reflecting over the traffic. Definitely, sometimes you want to say, yeah, I want to have a fast detection. But in that case, you have to be careful because you may end up with different kind of flip-flops in terms of traffic between the different gateways when you have some very small, small like duration fluctuations, and in the same time you want to, whenever you start doing some massive changes in the routing, like between the gateways, to be sure indeed that that's a good reason. So indeed the quality decreased. It's not just a temporary issue, but it's something serious. And
let me restart OpenSIPS just to clear its history and get a faster.
Okay.
Okay, so now we have a 2.1 MOS value. Let's see how this gets reflected here. Okay. Note that we might need to wait a bit for the MOS value to get to be updated. That's because we get the MOS value on at the end of the call, so it's not not reflected immediately. We have to wait for the 10 seconds for the call to terminate. Okay, so as you can see here, we have a low MOS value, and here calls started to flip. So instead of getting more calls, Gateway 1 started to get less calls than Gateway 0. That's because we put more value in MOS than in the PDD. So naturally, the quality is better when you have a better MOS. So as you can see in the graph, these two lines reverted. Now Gateway 0 gets even more calls than Gateway 1.
We say that let's say the degradation of the PDD, it's not so bad comparing with the degradation of the MOS. I mean, at the end of the day, the media quality should be more important in terms of taking the decision which is gateway is better or not versus the PDD. So now that we had the PDD the MOS degradation, then it simply swapped the order of the gate. It's saying even if it has a bad PDD, it's better with the audio quality. So at the end of the day, it's just putting together and aggregating in terms of meaning with different kind of statistics, different qualities in order to get the overall quality.
All right, so this was our workshop. I hope you enjoyed it. I think our time is off now.
I'm sure that there was a lot of enjoyment going on, Răzvan.
Thank you, David.
Especially seeing the crossover between the two gateways when the moth went down there. That's a nice piece of graphics. Thank you very much, Bogdan and Răzvan. We're very slightly over time, but we've built in these half-an-hour breaks. And so if you don't mind, gents, we'll keep you here for just 5 minutes more to see if there's any questions. Same drill as before for the audience. And by the way, I noticed Sobo Max sneaking into the audience there. So welcome along, Maxim. And
hey guys,
I also noticed Dan Christian Bogos hanging out there. Come to check us out because he's speaking tomorrow. Good to see you. Anyway, yes, let's take some questions from the audience, please. If you do have a question, click on the raise hand button, and that should bring you up to the top of the audience, and then we'll unmute you so you can ask that question. Who's got the first question there?
In the meanwhile, just a quick note. We will talk with I don't know, David, maybe you. If anyone is interested, we can share the material that we used for this workshop. So the scripts, there is no secret over there. So we will upload on some repository or so, and anyone can take a look at it.
Great, that's good to know. Thank you for that. There is a question that's popped up in the chat, so let me just read that out. It says, how do you configure the precedence of statistics to decide which one has more weight on the routing decision? For example, how did MOS get weighted more than PDD?
It's in terms of evaluation, all of them are on the same level. What's the difference is what pen inflict whenever the, let's say, threshold occurs. For example, in our case, the PDD degradation was translating in a 0.5, so reducing the traffic to half, while the degradation of MOS was translating into cutting to 30%, so it's even worse. So putting together then this kind of a score, it will calculate the overall score of the gateway, by simply adding the score of each statistic.
Okay, I think Bogdan is off.
Yes, he's going in and out a little bit.
And then
Okay.
Do you want to jump in, Răzvan?
Yes. So basically, of course, it's not an easy answer in terms of, it depends on what you want to provide to your customer. In order programmatically, that's quite simple. As you've seen, all you have to do is use a different weight, a different penalty, a higher or lower penalty in the database, and that will sort it out. But probably the decision is way harder because it depends on your business. Right. It's a business decision. Yeah.
Yeah. Okay. Well, that's a good answer in terms of the mechanics. Thank you, Răzvan. There's another question popped up in the chat, and it's saying, can the statistics be combined with LCR? So I guess what the Theodore is asking is, can you do least cost routing based on what you're getting in this quality?
The answer is yes. You can easily simulate that by considering the cost of a gateway, the cost of a minute, let's say, by considering it as a different statistic, and give it a weight, give it a penalty, and so forth. So you can think of the cost as a different statistic.
Okay,
and
I see.
You can easily simulate that.
Thank you. I see Ahmed in the chat has asked, can statistics integrate with the dispatcher and nodes in it? And I guess that's a similar question, isn't it? Can you dispatch to different places based on the weights? Based on the quality.
The answer is no, and it's just because you shouldn't do it. I mean, dispatcher it's only used to you have a couple of destination. Use those destination based on whatever algorithm you want. But with dynamic routing, it's a bit more complex because it's prefix based. So you can have different sets of gateways for different sets of prefixes. So of course you can always simulate a dispatcher behavior using dynamic routing. So more or less the answer is yes, but not exclusively with the dispatcher module.
Okay, thank you, Răzvan. We'll take one more question. I'll read it out from the chat. I noticed Flavio and Giovanni are in here. It's turned into an OpenSIPS hangout, this, hasn't it? All our favorite players. Eugene asks a question in the chat and says, when setting up these thresholds, you demonstrated how it applies to penalties. When a node corrects and it crosses the threshold in the other direction, does it go back the other way too, or does that require additional code?
Of course, yes. It doesn't require any additional code. Everything is automatic. It will just, so the penalty will just go take off, and it will receive the full amount of code that it should receive.
Okay, all right. They're coming thick and fast now. There's another question in the chat. I'm going to make this the last one, and then we'll go over to the informal kind of thing where people can jump in and ask their own questions. But I'll read this one out from the chat. It's Adolfi says, when a rule is configured with the carrier weight instead of the gateway, are all the gateways that belong to this carrier affected by the penalty?
Yeah, that's a good question, and I really don't know the answer. I'm not sure if Bogdan knows it. I'll have to check it.
I think it's per gateway.
Okay.
Yeah, I'm also pretty sure it's per gateway.
All right, that's great. Gentlemen, let me say thank you very, very much for giving of your time and resources to come and join us at ClueCon. We always appreciate you being part of the schedule, or if you're in the States, the schedule. Here we appreciate your participation. So thank you very much. I'll give you a little mini round of applause since I'm the only one that's got audio there.
Thank you for having us, David.
Yeah, thank you for being such a great host with us. And a pleasure each time to be part of the event.
Good. Well, thank you very, very much. What we're going to do is we're going to go kind of unofficial now, and we'll leave it open for people to unmute themselves